And you know, the geo market right now is where there's a nascent satellite servicing industry. So maybe we could make a difference incrementally if we can provide some augmented power. But there's a real marketplace of tens of billions of dollars. There are real companies in operation, and there are real customers, 1,400 satellites that are active and operational. So that's not hypothetical. That's not 20 years in the future. You know, that's an opportunity structure that exists right now. And so what can we do that can incrementally make a difference in that market? Well, if we could extend the operational life of those satellites, if we could double it, well, that's a pretty significant savings in the capital. We're looking at capital perform in a way that wouldn't have done otherwise. If we're looking at something that's more nascent, if we can co-orbit and develop manufacturing things that are more feasible in a free flyer, then we can begin to see some of the things that have been long talked about but not yet done in terms of material processing and manufacturing and associated with the space station. There's a lot of talk about commercial platforms, but you know, nothing that I've heard that begins to compare with a 100,000 kilowatt array, and it doesn't seem to make sense that we want to dump that in the ocean. So maybe there's an evolutionary path simply because we have a large platform and it has docking facilities and it has mobile servicing capabilities, and even if some of the other lab components and other things would be deorbited or detached. It seems that we have a unique facility that has this particular strength in space solar power. So that's not imaginary. That's something that we have in our possession. But have we really used it for full development? And I think Gary's argument is no, we have not, and it's here. We got to grab that opportunity. So I think there's a range of ideas. It shouldn't be just Gary up here talking about that. And I think that's an open invitation to address the question, what can we do now as well as what can we do next? You know, the original challenge, if you look at what it costs to put power out, to develop that power system, it's 10,000 times more expensive to have a kilowatt hour on the space station than baseload commercial power. That's a really big gap. And there's a long road to get to space solar power at a baseline level. Of course, we have designs, and that's a driving vision. But in the near term, it's what can we do in the next 2 years? What can we do in the next 5 years? What will investors buy? How can people extend the life? If we're looking at the lunar surface, Resource Prospector, for example, has an operational life of 1 lunar day, $300 million to go out and drill a few holes. Well, that's a pretty unexpectedly high cost. If we could even have some surface power maybe to reach down into those coal traps or to keep it warm during the lunar night, if we could double, triple, or make it perform more like a Mars Science Lab rover, then we have these amazing vehicles on Mars that are operating for years. But the moon is a much tougher environment. So there is a big opportunity to try and improve the return on investment that we make as we're going out to assay resources on the lunar surface. And it may be a fantasy that there is operationally useful ice. We just don't know. We're going to have to go and look at and survey it. There's a lot of conjecture about, we have a lunar fuel industry that may be there. There are some other technologies in this, but power is going to be part of that equation. So we're going to have to get a lot more cost efficient. So there's an opportunity for use of space-to-space power on the lunar surface, and a particular piece of hardware that should be much improved. What we have right now is still a fairly crude prototype, and we're going to have to be much better getting the cost down and going and running around on the lunar surface and making our equipment last. Mm-hmm. So that's added value. That's another way. And the customers are people who want to put stuff on the moon. So there's a big movement internationally to have rovers and pieces of to keep that stuff alive is a really big deal. And so the power part of that is where I think there's a strong opportunity. So I don't know how we're running, but I probably should shut up and let Joe.
I'm going to stand because I am numb from the waist down. I challenge this community to do 2 parallel track next steps. Come up with a consortium focal point and agree on the constituents for a demo or pilot by October 1st. And while you're doing that, I will find the millions of dollars needed to implement those two objectives. That's it.
Hey,
But it's up to you to come up with those two necessary things. Because if someone's going to give us the resources, we're going to have a repository that's transparent and it can be audited, and so there are no surprises. But damn it, I am at the end of my rope. I want to get this stuff moving. So you've got to come up with some next action steps to reach these two goals by October 1st. That's it.
well, hopefully, we'll see some interesting traction. There's some events that have occurred. One, we have, Cases has everything that they've asked for and then some in order to, respond to our resource allocation request. We've got, NASA HEOMD indicating that if we meet all the criteria, though they're even willing to consider direct funding. It's a hard thing to deal with, but if the associate administrator for HEOMD sends that, to you in a letter, might as well take him at his word. Okay, not a sure thing, but some interesting possibilities. Also, given the allocations, it's possible to go after, commercial resources. Okay, this becomes a situation where some combination of grants, contracts, both debt and equity financing, become possible in those regards. Also, conveniently enough, our mission budget considers both cash and in kind, and there are some of our partners that have extraordinary investments in relative scales in terms of internal R&D and contract work that they've done, germane to these areas that could make an extraordinary difference. I know a number of things that our colleagues here brought up, end up being very highly germane. We discovered in terms of chasing after money, the idea that we could go through and make a power plant proposal that looks just like any other power plant proposal, only it happens to be in space, turns out to be something that is in danger of being a tractable problem. And we can really see if we can make the case that there are economies of scale, and by our experimental efforts, prove it out. But can we entertain some questions from the audience at this point? We've got a few more minutes. Rom?
I'll try to be precise. I'm involved with a team that's got a 10-year contract vehicle from the Department of Defense and Congress. Can you hear me?
No.
Please repeat.
Yes, okay, that's better, yes. And so I'm involved with a team of people that took 20 years to develop a contract with Congress and the Department of Defense. It's an IDIQ contract. Definite quantity and definite quality. Because each is for 10 years. So we have the right to go to any federal building, any military base that's owned by the United States, and supply a solution. The priority was resiliency for the EMTP protection, but we could also add energy efficiency, which helps to pay for the EMTP improvements. So this can also include readiness, which is the space-to-space power beaming or anything we're talking about in these conferences, and that contract vehicle is in place already. If you define an agenda, what you want to do, you don't have to negotiate a contract. It's already there. It's unlimited as to what your scope is or quantity is. So we'd like to provide that.
Thank you, Ron.